welcome back to Fusion. This time we are going to do a video on meshing, just meshing, nothing crazier. A little bit of appearance in between, and to go from there. The next step will be, in a future video, actually running the simulation. Again, we uploaded from a step, same file as the other video that you may have just watched. This time we're meshing. Now, you might not have noticed this or used it yet, but inside of Fusion is a simulator or a simulation environment. It's quite good and is reliable as far as I'm told. But first, we have to think about this a little bit. The mesh should depend on the expected load. If we were going to use this in reality, the load is going to come through these parts somehow, the flats of the hex drive feature, and would transfer up through the part. It was mostly torque, maybe a little bit of bending or shear, and then would come out essentially through these flats or the edges thereof. So we're going to be trying to focus on getting the mesh tight, meaning quite dense around the points of interest and quite loose around the points of non-interest. Thinking about flow lines, we're going to have flow lines coming in, for example, moving up and through, it'll narrow through the waist, so we'd expect to see a little bit of higher stress or lower safety factor through here, kind of the same in here, and then it would transfer up and through and out of the flat faces or the edges of the flat faces. So again, gonna see how we go here. A little bit about color before. You'll notice this step comes with a bit of color. If you press A for appearance, you can see there's some colors that come with it, or appearances that come with it. These are editable. Just double click them. However, for us, we can see here that it's lost some color. If you want to fix this, just as a little demo, you can pick faces, draw a box. Oh, not the whole thing. That's strange. Pre-pick. Now, you'll notice right now I'm picking the whole thing for some reason. So what I can do is under select filters, I can turn off select all and body faces only. Keep in mind to turn this back on. Now I just get what I want. Pre-select appearance. Make sure it's for faces. Pick that color. Drop, actually drop it on and say close. We'll come back and change them to red, for example. Before we forget though, back to select all. Otherwise we won't be able to run our simulation right. Perfect. Let's go to simulation. Up on the top left, here's design. Partway down, simulation. It'll give you a little preview. There's manufacturer toolpathing, animation for showing people how someone's gonna, for example, work. Rendering, what does something really look like? Generative design, looking for shapes that are, lighter but rigid. Simulation is what we want. My screen goes a little bit sideways sometimes. I'm using an alpha here, so if it goes a bit strange, that's okay. Lots of different studies. You'll notice there's already a mesh here, so we're going to be meshing. All this stuff is fine. It's extremely competent, all of it, but we're just after a basic static stress. If you have problems in the future, there's a help. Great study. Does a bunch of work. See a different ribbon and a different browser. To get someone ready for simulation, you more or less move from left to right or top to bottom. For us, we're just going to do a very basic sort of prep. I'm going to fix the material and do our mesh. So materials maybe first. We're going to talk about simplify later. Shows you a preview of what it thinks it is. Steel. I'm going to change this to, here's one of my problems. In this alpha, this menu disappears for some reason. It still works. I'm looking for steel. There's lots of stuff here. 1050. So AI SI 1050. Say okay. You'll notice now that you're in study materials, you see 1050. Nice. Load cases we can do later in the next follow-on video. For now, we're just mostly concerned about the mesh. Turn on the mesh just as is. It'll ask you, do you want to calculate it? Say yes. Get a little feedback which immediately disappears. You can see the mesh isn't too bad. Now what's controlling this? If we look at this, we'll see that as, go away, whatever that is. If we see what's going on here, notice that anywhere where there's a tightening, like for example a fillet, it gets quite tight. Like these grooves are got a denser mesh than the big flat. So up here, for example, where not much is happening, we have quite a loose mesh. So this is kind of a problem. So what we need to do is kind of get everything right. One of the big advantages of this approach that the mesher uses from Nastran instead of Fusion is that wherever there's a tightness, usually you've got a KT. Usually when you have a KT, you have a stress riser. And when you have a stress riser, you're going to have a safety factor problem, potentially like an increase in tension, compression, whatever it is at that moment. The stress is going to get higher. So what we need to do is increase the mesh where we want it and decrease it where we don't want it. This is looking good in a way. This might be something of interest. And also round where this waist comes in. But we probably, well, we could be quite interested in here, but you can see in here a really tight mesh. Like this is quite janky. So let's have a look at what's going on here. If we look at the mesh, if we hover over mesh, we can see edit. Also under settings, you can see mesh settings in here as well. Let's go with the little edit button right here. Looks the same. So study type, that's fine. Mesh is all we're after here. We can see here that we've got 10% average element size. What does that mean? So we've got about 10 mesh elements per length of feature. So essentially 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-ish. Right, so with a complicated shape like this, it kind of fades away. If you have just a beam, it's very obvious. But you can see that this is in a way a large magnifier or a zoom setting. So if we, for example, have double this, so half it, model size is half of that. The mesh size is halved. We would expect to see about twice as much mesh. So generate the mesh again. You always have to regenerate. Go ahead and work away. It looks about the same. Got a little bit of denser, kind of up at the top and all that stuff. This is not a great way to control it. So one thing that we can do is use advanced settings. The only point I was trying to make before is it's not a great controller. I'm going to turn that back up. What we have here is the ability to have a little bit better control of the mesh. Maximum turn angle and curves is one of the biggest controllers. Maximum adjacent mesh size ratio and maximum aspect ratio. Each of these is independent. Let's do them all one after the other. I'm going to kind of work my way up. Minimum element size of average size. This means that this is basically controlled by the model base size. If we decrease, for example, our maximum turn angle, what this means is anywhere where there's a turning element, or like a fillet, a curve, a round, which this is almost entirely made of rounds, we'd expect to see it densing up. So let's regenerate. It may not be completely obvious what's going on here. So we can see here that we're getting a denser mesh around this waist, also in these waists. The problem with this is that even though it's quite a tight fillet, in the circumferential radius, it's quite gentle. So you can have a quite tight curve, but overly tight. Now, in another direction, like so for example, we can see this guy here, it's got some tight, bad, really kind of crazy, strong work that we're not really interested in. Like we are going to have some stress here, but it's not going to be as significant as some of the rest. So are we going to waste too much time? It's not bad. We might waste too much time, maybe not. See here that we're not doing too bad actually. Top, not much we can do about that. It's double bend territory. So there we go. That looks okay. Gonna rotate around. Try and fit this in a little better. Getting hooked on my keyboard. Let's try it again. Maximum adjacent size ratio. If we make this really small, what does that do? Makes the mesh tighter and also decreases the size. So now we had only a few meshes here, but we've tightened up around the waist. This isn't too bad at all, right? So this is good. Let's see if we do that again, but make it the exact opposite. Remesh. Simpler, less sort of short triangles, long triangles are now are allowed. So this makes very long, somewhat elegant shapes. It's also not bad. It's entirely up to you what you wish. Watch out for stuff like this, which is, again, because of this geometry downstream, there's not much we can do about that. What does the other one do? Make the maximum aspect ratio very small. Regenerate. Intensifies up in the flats. Keeps the curves quite loose. We end up with, not bad. Like we have quite tight where the curve is and then quite gentle right next to it. This can be good and bad. It depends how fast you're thinking your flow lines are clumping up. But again, this isn't too bad. Right, so it's entirely up to you what you think you need. But there's quite a lot of control you can have at this stage here. Let's look one more time. So we've ended up with quite a low maximum triangle, a high ratio, and a aspect ratio very small for the max. We can change the minimum element size, for example 10, half as big, and regenerate. Simplifies it even more. So then we have less going on in here. However, still got some problems in here. Let's try the opposite. $30. So the sets on the standard is 20. We use 30. Yeah, not bad, but then we're starting to lose granularity in here. We also have lost our complexity through the head, or the flats, which is where we're going to have some load. So 10 looked good. So basically you can iterate through your part, one after the other. maximum aspect ratio large. You have to watch out, otherwise you get turned into a loop just looking forever. Oh. Mesh error. Sometimes it doesn't give you, it doesn't throw out an error, it just says, no, I don't think so. Let's move it slightly. Oh, we're back to 10 here for some reason. I find this not too bad. Now, say we are happy with this. One thing that we can do is run a simplification. We have this kind of densification of mesh inside these fillets. Maybe we don't care. Let's use a simplify. Simplification is basically modifying only the simulation model, not the original. Here we are, repeated multiple times. We can use this to delete things on like particular details that we might be interested in not having. So for example, these guys, you can remove faces and you can remove features. We'll try both here. This comes up with a body sort of approach where you can select size with a slider. It can be a little vague if you just leave it as is. So this is what it's going to delete. But we might, for example, want to only remove fillets. So then we can see, there's the fillets that are, we want those for sure. Not so useful are these guys. So we press delete, close. Now, once we've got that, we can finish simplify. It's saved inside of the simulation model. The mesh goes out of date, rerun the mesh. Simpler, for sure. Is that what we want? Probably it's not bad. Now, for example, say we did want to actually control this. The last way to control mesh is with a local mesh control. In Fusion, it's stored under Manage, Local Mesh Control. You can select bodies and all that stuff. You can see it right now showing its sort of almost sort of beginnings of the mesh, what it starts with. This is the beginning of its mesh. But we can override it. So for example, we can pick edges, faces, whole bodies. But if you pick an edge, for example, there's these 6 that I might be interested in, that I deleted the fillet from. You can actually change the mesh size either by pulling the slider, which also changes the size. Should show an update-ish. You can also change it to just type it in. Regenerate the mesh. Didn't work. So let's edit that. Right now it's not happy. So we can unselect and try a whole body. One more time. I've put it down to 0.5, 0.25. It's hard to see. Maybe if you look along these edges here, it's getting a previously I'd made it too big, right? So we need to get to the point where we can see it. Maybe 0.5 is good. Rematch. This gives us quite a tight, uniform mesh. So not only have we solved this problem with overly tight fillets in here, we've given something that we're actually interested in a nice mesh. One advantage of doing all this is now we can go ahead here and add more elements to that same local mesh control, rematch. And there we have it. I would be fairly happy with this to get started. So maybe this is my first attempt at running a simulation. So from here on you would add loads, constraints, make sure that contacts, if we have them, are running smoothly, run the simulation, get an answer for things like safety factor. But for now, there we go. So 3 ways to control the mesh. 1, just adjust the mesh settings. So we're still quite high, but in advanced we've made some changes. The other one is to do a simplification loop, which gets rid of unnecessary features. But again, you should probably not run that until you see how the mesh goes, in my opinion. And then last but not least, and then sometimes extraneously, maybe you always want to not do this unless you must, local mesh control. As we did this, we saw it was easy to get it at the wrong size, but so it'll be a little bit of fiddling, and usually with typing in a length direct. That's it for me. Thanks for watching, and over to you.